For question number 1, what model are you using for this distribution of expected frequencies? First, we use calculator to create random data. Second, we use Microsoft Excel to find the distribution of expected frequencies. For the question number 2, do you think you are able to fulfill those assumptions when you wrote down the numbers? Yes, because we use independence of observation, which means that there is no relationship between the random data that we created.
Question 3. Can you think of a way to test whether your numbers have a similar frequency distribution to what we would expect for true numbers? Explain in details. A way to test whether your numbers have a similar frequency distribution is by using chi-square. Why? Firstly, it used to examine difference between actually and expected the data that we find. Second, the data is in the form of frequencies. Third, the total number of observation is greater than 20.
In question 4, we are required to use 1% and 5% significance for analyzing. For 1% significant, in step 1, which is state hypothesis testing and claim, our H0 are the numbers are true random number and H1 are the numbers are not true random number. In question state that if your number really are random, so we claim at H0. Step 2 is to determine critical value. Significant level or known as alpha, which is already given, which is 0.01. To find the degree of freedom, we use the formula n-1, and the value of our n is 41 minus 1, so we get 40. By referring the chi-square table, the critical value we got is 63.69. Step 3 is test statistic. From the table that we have construct, we got that the value of x squared is 38.58. Step 4 is summary. If we draw the graph, we can see that the value of x squared is not in the shaded region. So we can summarize that this graph is do not reject HO. Step 5 is conclusion. In conclusion, we can conclude that there is not enough evidence to reject the claim that the numbers are true random numbers. For 5% significance, the first step is step hypothesis testing and claim. For HO, the numbers are true random numbers, and the H1 is the numbers are not true random numbers. We claim at H0 as the question stated that. Step 2. Determine critical value. The alpha is 0.05 and the degree of freedom we got 40. So from the table of chi-square, the critical value is 55.76. Next is step 3. Test statistic. From the table that we have constructed, we have got x squared is equal to 38.58. Step 4. Summary. Since the critical value is greater than x squared, so do not reject HO. Last but not least is step 5, which is conclusion. For the conclusion, there is not enough evidence to reject that the numbers are true random numbers.